Section 4.7 on optimization. So optimization means find the minimum or the maximum. What's going to make this section even more fun is you will be given some words, and from the words you create your own function. And then you find either the maximum or the minimum. So these are going to have some applications like, what's the minimum amount of work that I can do to get the maximum grade possible? Create a function for that. So let's start off easy. Example number 1, find two numbers where the difference is 100 and the product is as small as possible. Okay, so from these words, create a function. So two numbers. So we could call the two numbers x and y. The difference is 100. So x minus y equals 100. The product is a minimum. So product means multiply. So this is the function, and we need to find the minimum. Now, this is a function of 3 variables because we got the p, the x, and the y. And I want to simplify it. So what I'm going to do is go over here and solve for one of these 2 variables. I suppose that it's easier to solve for x, so just add y to both sides. And then you take that and substitute it in for x right here. So now the function is going to be the product equals 100 plus y times y. Or if you multiply that out, that's going to be 100y plus y squared. And if you remember pre-calculus, the graph of this is a parabola. And because the number in front of y squared is positive, it's a parabola that is facing up, which means that at the vertex, it has a minimum, which is good because the question was asking for a minimum. Now, take this function and find the derivative. So p prime will be 100 plus 2y. Set the derivative equal to 0. And then we could subtract 100. You could divide by 2. And the y is equal to negative 50. And then if you substitute that in right here, then we could solve for x. So x will equal 100 minus 50. And so x is equal to 50. So the answer is 50 and negative 50. In here it just said find two numbers. It didn't say that they have to be positive, it didn't say they have to be negative. So one's positive and one's negative. If you subtract these two numbers, that's going to be 100. And if you multiply them, that's going to be negative 2500. That is pretty small. Negative 2500, that's the minimum. All right, then let's go on to example number 2. So for example number 2, find the point on this graph that's closest to the point 3, 0. So first of all, the graph y equals the square root of x looks like this. And then 3, 0 would be on the x-axis right here. So it's as if somebody throws a rock and it's going up. Well, no, a rock isn't a good idea. It would need to be a rocket because it's going higher and higher. A rock would go up and then back down. Okay, a rocket. So this rocket goes flying through the air. And then this point right here, when does the rocket get closest to it? So my estimate would be probably right about there. Because not right here, because it's going higher. So I'm thinking it's right there. Okay, next up, pick some point on the graph, some random point like this, and then this would be x comma y. But because y is equal to the square root of x, then I could write this point as x comma the square root of x. And then this point is 3, 0. And then find the distance between them. So I'll call this distance d. And then you could use the distance formula, which goes d is equal to the square root. Then you subtract the two x values and square that. You subtract the two y values, you square that. Add them together, take the square root of the whole thing, and that is the distance formula. And closest means we need the minimum value for d. So what's the smallest that d gets? So we're going to be taking the derivative and using calculus to do this, but I want to graph it and see, does this function right here have a minimum? Because if it doesn't, I probably set it up wrong. So let's see if this is even set up right. Take the square root of parentheses x minus 3 is squared. And then that just means the square root of x gets squared. So that's just x plus an x. And the graph, I should probably go out to about 5 or so, because I'm thinking the answer is right in here about 2, but I'll go out to 5, 0 to 5. Now the graph that it makes is not going to be this graph, because this is just the graph of y equals square root of x. So this is a function that gives you the distance, and we need it to be the smallest possible. Oh, it doesn't like my window. I think I was too busy talking and I didn't pay attention to... Oh, yes. So that's a function that has a minimum somewhere right about here. So it's going to be possible that, yes, we could find the minimum. So first of all, let me just simplify this a little bit. So this would be x squared. The middle, so I'm squaring this out, multiplying this out. The middle term would be minus 6x, and then plus a 9. And like I said, this is just going to be plus an x. And then still do algebra. So this is going to be x squared, and then combining the x's, this is minus 5x plus 9. And then take the derivative. And the derivative of the square root function is 1 over 2 times that square root function. Next up, do the chain rule. So the derivative of the inside will be 2x minus 5. Notice that you cannot cancel these 2's, because if you do, you would also have to have a 2 in there to cancel, which we don't. So then set the derivative equal to 0, And I know that the only way the derivative equals 0 when it's a fraction is if the top equals 0. Or you could set it equal to 0 and then multiply both sides by this. And when you multiply this onto that side, it's still going to say 0 times something. So it's still equal to 0. It's only the numerator that equals 0. And then add 5 to both sides. Divide by 2, and 5 divided by 2 will be 2.5. So my guess was pretty decent. Of course, I've done this problem probably 19 times over the years, so pretty reasonable that I had a good guess. X equals 2.5, but we're not quite done because it said find the point. So in other words, we need to also find y. So y is equal to, just plug that into the square root function, the square root of 2.5, the square root of 2.5. So the y value is 1.581. And then for my final answer in this little box, x is equal to 2.5. Y is equal to 1.581. Look at that, we're already done with 2 of them. Now for example number 3. So for example number 3, we're going to design a poster. So the print area is 400 square inches. The margins are 3 inches on the top and left and right sides. And the margin at the bottom is 5 inches. So in other words, this is going to be the whole poster. I forgot to say that it's a rectangular poster. So not a circle poster, but a rectangular poster. And then this is where the message is going to go. So in here, this is where the message is. It says, please wash your hands. And then this has to be 400 square inches. Now, when you measure this blank part, that's 3 inches. This is 3 inches and 3 inches. So generally when framing, these 3 are supposed to be the same, and then this should be that amount or bigger. So then this is going to be 5 inches. Okay, so now we need to create a function because we really don't know, is this part in here a square or is it more rectangular? We don't really know. So use a variable down here, this side. I'm going to call that x inches. And this vertical part, that's going to be y inches. Which means that x times y is equal to 400. So one equation is going to be x times y equals 400. Now, when you look at the bottom, this whole part down here for the size of the poster, So it would have x plus 3 on that side plus 3 on that side. So this is going to be x plus 6. Why did I write y? X plus 6. And for this side, well, this much is y, and then it's got an extra 3 and an extra 5. So this is going to be y plus 8. Now, I was so excited about drawing the picture, I forgot to write the question. I can do it right here. Create a poster with the least amount of paper possible. So save paper. So one equation we have is this. Now the amount of paper. So I'm going to separate them. So this one right here, we're going to be doing algebra with this one. And then with our main equation, we're going to be doing calculus. So this is sometimes called the auxiliary equation. And then this is the main equation. And with the auxiliary, we'll do algebra. With the main equation, we'll do calculus. So the main equation is how much paper? So P for paper. Well, that's just going to be one side times the other side. So that is y plus 8 times x plus 6. Now we could use this equation and solve for y. So divide both sides by x. And y is equal to 400 over x. And then substitute that into the main equation. So P as a function of x equals 400 over x plus 8. And then times x plus 6. And then I'm going to go ahead and multiply this out. So P is equal to, when you multiply these two, the x's are going to cancel. It's just going to be 400. When you multiply these two, it's going to be 6 times 400. So that's 2400 over x. Then distribute the 8, so there's going to be plus 8x. And then finally, 8 times 6 is 48. And I guess we could combine like terms, so P is equal to 448. And then plus 2400 over x and plus 8x. All right, now we're ready to take the derivative. So P prime equals, the derivative of a constant is 0. This one, I look at that as 1 over x, and the derivative of 1 over x is negative 1 over x squared. And the 2400 will just stay there. Then the derivative of 8x is an 8. Now set it equal to 0. And solve for x. Right now you might be saying, but wait, the derivative could be undefined if x equals 0. So actually we should look at that as a possibility. So the derivative does not exist if x equals 0. But then that means on this poster, this side is 0. And that's not a very good looking poster if you have one side that's 0. That's going to be really hard to see. So in this case, that doesn't really help. Then continue over here. So I'm going to take this negative term, move it to the left side. So it's going to become positive 2400 over x squared equals 8. And then this problem is so fun, I even need another piece of paper to continue. So then you could multiply both sides by x squared, and you could divide by 8. So then it's going to be 2400 stays there, divide both sides by 8, and multiply both sides by x squared. And so this is going to be 300. And then take the square root of 300. So x is equal to 17.321. And then we also need to know what y is. And a little while ago we had a formula for y right here. It's 400 divided by x. So 400 divided by my last answer is 23.094. Okay. Finally, the overall dimensions are going to be x plus 6 by y plus 8. So the final answer is, here's the outside of the poster, because that's how much paper is needed to make the whole poster. And we're talking about using the least amount of paper possible. So this is the outside of the poster, and this needs to be x plus 6. So if you add 6, that's going to be 23.321 inches. And for the y, we need to add 8. So that's going to be 31.094 inches. And that's how much paper each poster would use. Next example. So for example number 4. So now find the area of the largest rectangle inscribed in a circle of radius 10. And we'll use inches. So in other words, if you have a circle and its radius is 10, and then inside of that you make a rectangle, so you could make the rectangle sort of square looking like I did, or you could make a long skinny rectangle, but which one would have the biggest area? So find the area for the largest rectangle. Well, I need to come up with an equation. For one thing, a circle, the equation for a circle is x squared plus y squared equals the radius squared. Now, this point right here, that's where the circle and the rectangle meet. So this point, which in general is x comma y, that's going to be a point on the rectangle, and it's also going to be a point on the circle. And if that's x, y, that means going from here to here, that's x, and going from here to here, that's y. That means that the total width of the base of the rectangle is going to be 2x. And then the height will be 2y. So then for the area of the rectangle, Well, area just means, for a rectangle, just means multiply the two sides. So this side would be 2x, and this side would be 2y. So the area is 2x times 2y. So this is the auxiliary equation. So we're going to do algebra with that. This is the main equation, and we're going to take the derivative. But first, I want to replace y. So if you go over here and you solve for y, so it would be y squared equals 100 minus x squared. And then take the square root. So it's going to be the square root of 100 minus x squared. And then take that and substitute it in right there. So there will be a 2 times 2, so there's 4, and there's already this x. And now replace the y with the square root of 100 minus x squared. And there is our main equation. Now we're supposed to find the largest possible. So in other words, this should have a maximum. So you don't have to graph it, but I like to graph at least every once in a while to see, am I on the right track? So is this a function that has a maximum? So I now need to set the window. So looking at this, the very biggest x could get is 10. So change the window, go from 0 to 10. And what could the area be? Well, if it was a 10 by 10 rectangle, that would be 100. That would be the absolute biggest it could get. And it looks like it's even bigger than I thought. Let me see, how big is it? Oh, it's up there in the 180s. Oh, that's because I have to double it, so it would have been 200 to 200. Okay. No, not the X, Greg. Sorry, Mr. Perkins. The Y. Oh, just barely made it. So yes, it does have a maximum right there. So largest, yes, that's possible. Excellent. Now take the derivative. So for that, use the product rule. The derivative of 4x will just be 4, and then leave the square root alone, plus 4x, and now take the derivative of the square root function, which is 1 over 2 times the square root function. And then don't forget the chain rule. The derivative of the inside will be negative 2x. And then set the derivative equal to 0. And this one can't be simplified, so just recopy that for now. This one could be simplified a little bit. I could have these 2's cancel and then multiply this with that, so then it's going to be minus 4x squared over the square root. Okay, so we're able to simplify it a little bit. Then what I'm going to do is clear out this denominator. So I'm going to multiply both sides by this. So multiply by the square root of 100 minus x squared. Also multiply this one by the square root of 100 minus x squared. And also multiply this side by the square root of 100 minus x squared. So on the left side, that just stays 0. With this one, it will be a radical times a radical, so that gets rid of the radical. So it's just 4 times 100 minus x squared, no more radical. And over here, they cancel, so then it's going to be minus 4x squared. And then we're almost done. So distributing, this would be 400 minus 4x squared minus another 4x squared. And then We could combine the 4x squares, that would make -8 of them, and then add that to the other side. And I'm going to try to finish it on this piece of paper because we're trying to save paper. So if you divide both sides, 400 divided by 8, that's 50. So x squared equals 50. And then take the square root of that. So whenever it's word problems, you should give a decimal answer. So I could put 5 square root of 2, but it's better with word problems to give the decimal answer. 7.071. The reason for word problems having decimal answers is because if this was an application and you were on a construction site and you were the architect, and then you say, okay, I've figured out all this math and everything, and then you go out to the job site and you can tell the construction workers, okay, I need you to make the rectangles so that they are square root of 50 on each side. And they're like, what? Oh, sorry, it's 2 square root of 10. No, it needs to be 7.07 inches. And then last, find out what y equals using this equation right here. So then y is equal to the square root of 100 minus the 7.071 squared. The square root of 100 minus, and then I'm just going to plug that in. The last answer that I had, but it was squared, and it turns out to be the same. 7.071 inches. So since these are the same, that means that this actually should be a square. So the final answer is that the rectangle is 7.071 inches by 7.071 inches, but I actually said find the area. So times, or I could just say times itself, so squared, so it equals 50. And there it is.